today's video, we're going to be doing a graph analysis with a no calculator question released from the AP exam. So the question says, let f be defined over the closed interval -5 to 5 with f of 1 equals 3. The graph of f prime, the derivative of f, consists of two semicircles and two line segments as shown above. So semicircle here, here, and then two line segments, which makes a triangle. For -5, for the interval -5 to 5, find all x values which f has a relative maximum and justify your answer. So we know that relative maximums of the original function occur when the derivative changes from positive to negative, because let's think about this, that's when that slope is changing from increasing to decreasing. So that happens two places. That happens at -3 and +4. So I'm going to say right here for part A, f has a relative max at x equals -3, 4. Note that I didn't say it has a relative max. I used the function's name. So f, make sure you're using names. That's a big thing that they're looking for. F has a relative max at x equals -3 and 4, and then we need a justification. So because f prime changes from positive to negative at those points. So again, f prime, f, using names, no pronouns. Part B asks for any points of inflection. So what we're looking for in part B, let's get a little zoom. There we go. What we're looking for in part B is where is it changing concavity. So we do know that we're looking at the double derivative. We only have the single derivative, so I'm just looking at the slopes. So that really means when that single derivative is changing from positive to negative slope or doesn't exist. So let's look right here. It's happening right here at -4, at -1, and at +2. So I'm going to say f has a point of inflection at x equals -4, -1, and +2, because f double prime equals 0 or d and e, because those are our two conditions. That slope equals 0 or does not exist. And then we also need to say and f prime changes from positive to negative or negative to positive. Oh, and I messed up here. Make sure you're saying f double prime, not f prime. F double prime changes from positive to negative or negative to positive, because even if that were 0, if I kept on increasing, so for example, like that -4 piece right here, let's say it like kind of flattened out, but then it kept on increasing, even though like we have a flat slope, we're still increasing, so it's not actually going to change concavity at that point. Part C is two-pieced, so we want all intervals on which the graph f is concave up and also has a positive slope. So let's start with the beginning, concave up. We know that f is concave up when f prime is increasing or when f double prime is going to be positive. So I'm going to say f when f prime is increasing dash f double prime is greater than 0. So that's happening on a few intervals, and I'm just going to write those down here. That happens from -5 to 4 and from -1 all the way to 2. So -5 to 4, -4, union -1 to 2. The second piece asks us when it also has a positive slope. So we know that it's going to have a positive slope when f prime is greater than 0. So that happens from -5 to -3, and also from 1 to 4. Now, we want to combine these two, so I'm going to say f is both concave up and has a positive slope from -5 to -4 is our first, and also from 1 to 2. That's where both of those conditions are met. And if you said both of these clarifying statements above, then your answer is, or your justification is there. But let's say that you just said this closing statement, then I would have to say because f prime is greater than 0 and f double prime is greater than 0. And there would be my justification. Let's look at this last part. Find the absolute minimum value of f of x over the closed interval -5 to +5 and explain your reasoning. Now I know that when I have absolute minimums, you always have to check your endpoints. We also need to check where f prime is going from negative to positive. If you think about it, negative to positive, that's where that minimum is going to occur. So I have 3 points that I need to check. I need to check f of -5, I need to check f of 1, and I need to check f of 5. Now, to get f of -5, I'm going to use the fundamental theorem of calculus. So I'm going to say here, by FTC, f of -5 equals, because we had an initial value at the very beginning, it told us that f of 1 is 3. So I'm going to say f of 1 plus the integral from 1 to -5, f prime of t dt. And then I'm just going to substitute in. I know that f of 1 is going to be 3. I also know that this integral is not in the correct order, so I'm going to flip that. So it's going to actually be minus, let me get my eraser, minus the integral from -5 to 1, f prime t dt, and I can get a value for this right here because I'm really just looking from the area from -5 to +1. So let's come up here, let's get rid of all this work that we did earlier. And we need to figure out how much value it's going in this semicircle and then this semicircle combined. So I know that the area of a semicircle is half of pi r squared. I know that the radius here is 1. So I'm just going to say that this 1 squared is 1. So this area is pi over 2. And then this area, we have a radius of 2. So it's going to be 4 pi over 2. Or -2 pi because it's underneath the axis. So I'm going to come down here and say that this is going to be equal to, let me get some room. We have 3 minus pi over 2 minus 2 pi. Let's get this next piece done. F of 1, I already know that f of 1 is going to be 3. It's already given. And then my last piece right here, f of 5, by fundamental theorem of calculus, f of 5 equals f of 1 plus the integral from 1 to 5 dt. That equals 3 plus, let's see what that area is. So from 1 to 5, we have 2 triangles. It's going to be 1/2 base times height. So our base, 1, 2, 3, our height is 2. So 1/2 3 times 2. So this is going to be positive 3. And then the same thing here, 1/2 base times height, so that's negative 0.5 plus 3 and a negative 0.5. Now, I can see already that my smallest value is going to be positive 3 because when this negative distributes, that's going to be a larger value than 3, and then adding that together is also going to be a larger value than 3. So I'm going to say absolute minimum of 3 occurs at x equals 1 for f of x. And then we are done.